I want to prove that this equality is true. In order to prove this, I need to use the law of cosines. So let's look at the norm of v plus w quantity squared. That is the square root of norm v squared plus norm w squared plus 2 times the norm of v times the norm of w times cosine theta, and then the whole thing squared. So the square is going to cancel with the square root, and I'm going to be left with whatever's in the inside. And then for the norm of v minus w quantity squared, it's going to be the same thing, except I will be subtracting by 2 times the norm of v times the norm of w times cosine theta. Now the next step, I'm going to be subtracting the norm of v plus w squared with the norm of v minus w squared. And notice that the norm of v squares and norm of w squares cancel out, and I'm left with 4 times the norm of v times the norm of w times cosine theta. And recall that formula is just a dot product. It's just another formula for the dot product. So that proves it. Now what if v and w are orthogonal? So let's look at the same formula, and because they're orthogonal, the angle is 90 degrees. So let's plug in theta equals 90. So on the right side, we know that cosine 90 is 0. So 0 times 4 times the two norms will just give me 0. And then I can move the norm of v minus w squared to the right side, and then take the square root of both sides. And so what I get, if they're orthogonal, is that the norm of v plus w is equal to the norm of v minus w. And that completes the proof.